All right, so I'm going to show you how to make a slope field for when there is a derivative that has a y in it. So on Thursday, we did a slope field for a derivative that had just x in it. So it didn't matter what y was when we made our slope field. Now we're going to have a derivative that has a y in it. All right, so we're going to make a slope field for y prime equals y. All right, so I'm still going to make a table of values. All right, so for this equation, it doesn't matter what x is, because there's no x in this equation. It only matters what y is right now. So let's make ourselves a little Cartesian plane over here to start looking at what this looks like. All right, so let me start with 0 for y. So if y is 0, then the derivative is 0 as well, because when I put 0 in here, I get y prime equals 0. So when y equals 0, I don't know what my x value is, but for my y, it's going to be 0. So it means 0 slope. Looks like this. So for all x values, I'm going to have 0. All right, so now let's do y equals 1. So for y equals 1, my derivative is 1. So at y equals 1, which is right here, no matter what my x value is, my y value is going to look like this. My slope, 1. Okay. And then when y is equal to 2, my slope is 2, because 2 in this spot just gives me 2. So now when I go to y equals 2, I have a slope of 2, which is going to be more steep. Okay. And then I keep going. If I put in 3, plug in 3 here, I get 3. So that's even more steep for 3. Okay, and now even if I pick some negative values for y, so let's say y is -1. So if y was -1, my slope would be -1. If y was -2, my slope would be -2. If y was -3, my slope would be -3. So if I came down here to -1, my slope would be -1 for all x's. And if I came down to -2, my slope would be -2. So more steep for all x's. And if I went down to -3 again, more steep. And you could see the pattern that this slope just continues to get steeper in the negative direction or steeper in the positive direction, depending on what side of the x-axis I'm on. So I can actually see what this function looks like, because if I look just above this dotted line here, it actually takes the shape of an exponential. So this slope field is describing an exponential. If I look up here, it's an exponential, or if I look below, it would be an exponential approaching that x-axis there with a dotted line. All right, let's check another one out with a y in it. All right, let's check out the slope field for x over y. All right, so I'm going to make a table of values for this. And this one's even a little more different because it has an x and a y in it. All right, so we're going to have to play with this a little bit. So let's pick a value for x. So if x was, we'll say 0. If x was 0 and y was 1, then my slope would be, or my derivative would be 0. Okay, so when x is 0 and y is 1, so 0, 1, that's this point right here, my slope is 0. So a completely horizontal line. And you know what? If x is 0 and y is 2, I still get 0 because 0 over 2 is 0. And if x is 0 and y is 3, I still get 0. So for all of my x values where x is 0, for all my y values where x is 0, I get a derivative of 0. So that means that every single y value will have a horizontal slope. I don't do that one because we didn't do that one. Okay. All right, now let's check out another one. So for these are kind of funny because you have to try to look for a pattern. So let's switch the x value now. So let's switch the x value to 1. So if my x value is 1 and my y value is 1, then my slope is 1. So that means at 1, 1, so 1, 1, which is right here, 1, 1, my derivative is 1. And now I'm just going to see, all right, where else would I get a derivative of 1? So how about 2, 2? 2 over 2 is 1. 3, 3 is 1. 4, 4 is 1. So I found a little pattern here. So 2, 2. So if I go over 2 and up 2, I'd have a derivative of 1. If I went 3, 3, I'd have a derivative of 1, and so on. So I saw my pattern here. 1. And if you notice, I'm avoiding 0, 0 because we know something funny happens when I have a 0 in the bottom. All right. Let's try another pattern. All right, let's pick another x value. So how about, let's get some negatives on here. How about if I picked -1? When
are you going to be done?
Okay, sorry, got a visitor. All right, so now let's see what happens if I look at -1 and I'll make -1 and I'll make +1. So I'm just sort of like just trying to come up with points to see where, if I went around the Cartesian plane, what would the derivative look like? So -1, +1. So that would be -1 over +1, which is -1 slope. So -1, +1 would have a -1 slope. So now I'm going to look for all the other places that would get me a -1 slope. So how about -2 over 2, -3 over 3, -4 over 4. All of those would get me -1 slope. So I could start coming up with a pattern here. So I have -1, all these guys here. And guess what? How about if I did +1, -1? Still getting a -1. +2, -2, -1. So I know that this whole entire diagonal here is going to be like that too, a -1 slope. And I could keep coming up with different values to see how I should fill in the rest of my slope field. So you'll just keep messing with this table of values till you fill everything. So say I found 2 and 1. So 2 and 1 gives me a slope of 2, because 2 over 1. And what else gives me 2? 4 over 2 is 2. What else could give me 2? How about -2 over -1? That gives me 2. How about -4 over -2? That gives me 2 as well. And then I could fill in my slope field for those points. So 2, 1 has a steeper slope. And then 4, 2 has a steeper slope, and so on. And then you would just keep using these points to fill in as many marks as possible on the slope field. And just so you can see what the actual slope field looks like, once you do a whole bunch of points, that slope field is going to look like that. So there are slope field generators actually online. So if you ever wanted to check yourself as you're going through, you can generate a slope field. All right, so you are going to try one on your own, and then you'll post the picture and then press turn in. And then this will be one of our last new lessons. There's only one more new lesson past this.